Okay, let's start with the first one. Josh, I'll start there with you. What did you do to get to the answer? Good. Who got it right? You didn't guess the answer, ne? I know we know the answer before we started, but we're practicing the method, ne? Okay, B. Nikita. Okay, so number one, your answer is wrong. Number two, you try to guess it. Okay, that's the problem. Because you're not doing a method. So you are not listening to me. So if that's the case, you're not going to do the things the way I'm teaching you to do it, then you can just leave the class. Okay, that will be better. The class was recorded. Peter? Okay, now what you've done here is you've divided by 4. Right, now look here, when you cancel out, the 4 is cancelling out, am I right? What is left on the left hand side? Negative? No, the 4 is cancelled out. Negative x is left. Is x alone? So what should you divide with? But it's right that you're dividing by 4. But I'm saying now what will remain is negative 4. Which means that x is not alone and we need to get x alone. So the negative is still a problem there, do you see? So we would rather divide with negative 4. So that the negatives can also cancel out. Does that make sense? Okay? And then on this side, I'm also going to divide with negative 4. Do you all understand that? The negative and the 4. Now x is alone, Ritan. What is a positive divided by a negative? 32 divided by 4? 8. Okay, see? Tot verder. Very good. D? Good job. Okay. E, now we don't have the number next to it. No? We have it underneath it. Okay, so what did you do to get x alone here? Times 6, very good. And now the scale is tipping. What must I do? Very good. Here the 6's will cancel, no? And then I'm left with x, and then what's your answer on the other side? 54, very good. Okay, F. Very good. Okay, and then G. And then X is? Very good. Okay, do you all understand these ones? Good. Today we are going to learn one other way, and then we're going to look at the exponentials, and then we're going to practice it. Okay. So, the example we're going to look at today, you don't have to write a new heading. If you drew a line, you can just write algebraic equations again. We're just going on with this. So if I write down this example, let's say 24 over x equal to 6. Can you tell me how this one looks different from the second examples, the last two examples that we did yesterday? Yesterday's last two examples was y over 8 equal to -3 and x over -3 equal to 4. Now today's example is 24 over x equal to 6. Can you tell me how this one looks different? Yes, the variable and the number is swapped around. With the previous examples, the variable was at the top, so it was x divided by a number. Now it's a number divided by x. Okay, now I don't want you to write down now. Just quickly look here. I will tell you when you can write again. Maybe some of you are now saying, okay, well, we follow the same method, which is fine. I put a 24 at the bottom so that it can cancel out. And then I put a 24 at the bottom here. Right. What's going to be left on this side is 1 at the top over x. Do you see the problem? The x is not alone when I do that. Now, working like this, yeah, I would have 1 over 4, and then you can go on. There is a way of getting it right, okay, but it's going to take us a bit longer. So you see the problem, putting the number at the bottom doesn't solve it like it did with the previous examples. Okay. Now I'm going to show you a way to do it mathematically, and you are welcome to use that way. And then I'm going to show you a shortcut method that you can also use. The shortcut method we also use a lot in physics in grade 10 and 11 and 12. Okay. So mathematically what happens is I'm going to put the x at the top because we need to get rid of the fraction. I'm multiplying with x. Okay? That will make the x cancel out here. But do you agree my scale is tipping now? So I'm going to have to multiply with x on this side as well. So I am left with 24 equal to 6x. Moet ek iewers teken of iets?
Net hier so as dit. Net hier.
Okay, and after I've done that, do you see now it looks like the first examples? The first two that we did, where the number is in front of the variable. So what did I do here to get rid of the 6? I would divide with 6. Then it will cancel out. Because you remember I said x must just be alone. Doesn't matter which side. Must just be alone. If I do that, I get rid of the 6, but the scale is tipping. So I have to do it on this side as well. And then I've got x equal to 4. Does that make sense? Okay, you can quickly copy that. This is how we do it mathematically, what's happening. Okay. Alright, while you're just finishing that, I'm just going to start talking to you. Now, in order for you to be able to use this shortcut, you need to see when it's the sum where you can use the shortcut. Okay, so how do we identify? The unknown is in the denominator. Do you see it there? The position of x is that it is the denominator of the fraction. It's the part that makes it a fraction. Okay, and that's the problem. Okay. What we are going to do when we see this situation, without changing anything, we are going to take the denominator and we are going to take the answer and swap them. So this is not what we do, what happens mathematically. There's not something like swap in maths. Okay? This is a shortcut. We literally just swap those two numbers. The denominator and the answer. Can you do the sum now? Is the variable alone? And are the numbers that are the same type of numbers at the same side? What is 24 divided by 6? And x is there. Now, if you look up at the mathematical way there, do you see when we divided by 6 there it cancelled out? We were also dividing 24 with 6. And we also got the answer of 4. And that's it. That's the shortcut. Just swap the denominator and the answer. And then you do the sum. Okay. I'm going to do another example. Where is the variable? In the denominator. What does that mean? It means we can use the shortcut. What are we going to do? Swap the denominator with the answer. Without changing anything, you don't do anything to them. It just becomes 28 over negative 4 equal to b. P is alone, that's what I wanted. What is a positive divided by a negative? 28 divided by 4? 7. Will you be able to do that? Okay, that's easy, ne? So the hardest part in this sum is just recognizing when you can do the sum. And that is when the variable is in the denominator. Right. Now there's something else that I just quickly want to show you. You will notice these sums at activity 7.2 from M to R. Okay. It's sums where they want to know what the exponent will be. What will the exponent be? Do you see it here? I've got it here on the board. So for example, I can give you a sum. You're all gonna know this one. Don't write this down. I can give it to you as 3 to the power of x is equal to 9. What must 3's exponent be to be 9? 2. Once again, something you know. Right? So when you're going to do these ones, you can guess it, it's fine. But I want to show you how we are going to do it in grade 10 and 11 and 12. So those of you that are considering going on with mathematics, I want you to try to do the sums in this way. Okay, so there's a rule. I'm going to take this one as well. That says you cannot work with two different types of numbers. Okay, so what I mean is this number is in an exponential format. It's got a base and it's got an exponent. Where 9 is just a normal number. We know it has an exponent of 1, okay, if we wanted to put it there, but as it stands there, it's a normal number. So our first step would be to get them both to be exponential, because you cannot make this a normal number, because we don't know what x is. That's what we have to find out. So we want to make that one exponential. So we want to write a number in exponential form that has the same value as 9, but that has a base and an exponent. Right. The reason we want to do that is we want, and it's always going to be like that, we want these bases to be the same. And when they are the same, you can throw them away. Okay? So what I'm going to do, I look at 9. I want it to be written exponentially. I just said we want it to be the same number. We want the bases to be the same. So that already gives you a hint of what it has to be. It has to be 3 to the power of something. Okay? So now I check. 3 times 3 is 9. It works for that one. So I'm going to say this side is 3 to the power of x. This side is 3 to the power of 2. Do you agree? These two things are the same. 9 and 3 to the power of 2 is the same. Can you see these ones are now the same bases? And when the bases are the same, you just don't use them anymore. So you can just say x is equal to 2. Because that's most true. Ne? What must x be? 2. Let me do another example for you. Just don't want to do ones that are given there. Okay. 2 to the power of x is exponential. 8 is a normal number. Okay? I want to rewrite 8 so that it is a base with an exponent. The base must be 2 because it has to be the same as that. So 2 to the power of what will be 8? And I know you all know, but if maybe you don't know, you say 2 times 2 is 4. Times 2 is 8. Okay? So it has to be written as 2 to the power of 3. So what is x? X is 3. Must I do another one for you? Okay. '81 must be written as an exponential form. But the base must be 3. We know it must be 3. It cannot be 9. Okay? You cannot say 9 squared because then the bases won't be the same. So this one must be 3 to the power of x. This one must be 3 to the power of something. So all I need to do is determine 3 to the power of what? Now, if you're in an exam and you are unsure, you are welcome to use your calculator as well. Okay, so I'm going to say, what is 3 times 3? What is 9 times 3? What is 27 times 3? 81. So what is x? X is 4. You're getting the hang of it? Okay. But if you prefer in grade 8, we actually just have to guess it. So 2 to the power of x equal to 16, what is it going to be? Then you can just give the answer. But, as I'm saying, especially those of you considering going on with mathematics, practice it, try to get it like this. So you get your bases the same, and then you throw them away, you just write the answer of the exponents. They do tend to use this as a level 4 sum in the exams. But I will show that to you later on, okay, the way that they do it. Or I can show you now. Let me show you now, while we are busy with it. Okay. So what they can do is they say 2 to the power of x minus 3. Do you see that's now the whole exponent? X minus 3 is equal to 32. What did I tell you? What must we do? We must write this as exponential. Okay? The exponential must be 2 to the power of something. Okay, now let's see how many times we have to multiply with 2 to get to 32. And it's always going to be one that works. Okay, it won't be something different. So it's 2 times 2 is 4. Times 2 is? Times 2 is? Times 2 is? So this one is to the power of 5. Now what did I say? What do we do once we've done that? We throw the bases away. So I'm going to say x minus 3 is equal to 5. And we're going to get to these type of sums later on. But do you remember inverse calculation? Inverse? So this is x minus 3. What is inverse of minus 3? Plus 3 and plus 3. Then I've got x equal to 8. That's what I do in the exams in November. Okay. But we have some of them in the assessment activity that we will do when we get there. You see, we still need to do those 2-term sums. After that, we can practice them. Alright. So that's what we are working towards. But before we can get there, we are first just practicing these ones. So what I want you to do for me now is same activity, 7.2, page 93. You have to do from H to R. H to R. And then tomorrow, you are here for the last period, ne? So, tomorrow, we are going to work. But from next week, we are going to work harder during the week. From Monday to Thursday. Because I don't want to work on a Friday, the last period, ne? Because then you guys are not concentrating anymore. So we work harder, Monday, Tuesday, Wednesday, Thursday. And if we are done with our week's work, then we can just mark on a Friday and rest, like we did some Fridays last term. Okay. But then you need to work with me. You have to be on time for all of the classes. Homework done. When we mark, you give the answers so we can go through it quick. Is that the deal? Yes. Sharp. But tomorrow we are still working. So you mustn't be tired when you come here.